Good morning, class. We are looking at analytic trigonometry, the inverse, sine, cosine, and tangent function. So we're going to cover the inverse sine, cosine, and tangent function, and the inverse trigonometric functions will continue later on. The objectives are find the exact value of an inverse sine, cosine, or tangent function. Find an approximate value of an inverse sine functions. Use properties of inverse functions to find exact values of certain composite functions. Find the inverse function of a trigonometric function. Solve equations involving inverse trigonometric functions. So, what did we discuss? In short, we looked at the concept of fundamental identities, starting with a unit circle, x squared plus y squared equals 1. A point has coordinates x comma y. Therefore, we define them as cosine and sine. X represents cosine theta, y represents sine theta. It becomes very easy to figure out the quadrantal angles, and having x squared plus y squared equals 1 continues here. Sine is defined as y, cosine is defined as x. Tangent is the ratio of sine to cosine, so y to x. Cotangent is the reciprocal of tangent, cosecant the reciprocal of sine, and secant the reciprocal of cosine. And it makes life easy when we have those. And if we go with a circle of radius r, then sine that was y becomes sine equals y over r, and the rest of it. Periodic functions. The period for all trigonometric functions is 2 pi, except tangent, and with tangent goes cotangent. All trigonometric functions are odd functions except cosine, which means cosine of minus x is cosine x, and with cosine goes secant, secant of minus x also secant x. And these are called fundamental identities. We have Pythagorean identities, quotient identities, reciprocal identities. Those are extremely important to get us started. Pythagorean identity starts with sine squared plus cosine squared plus 1 and continues. Quotient identity starts with tan is sine over cosine, cotangent is cosine over sine, and reciprocal identities was basically mentioned here. Cosecant, 1 over sine, secant, 1 over cosine, cotangent, 1 over tangent. By the way, when sine squared and cosine squared, they add up to 1, you can divide both sides by sine squared once, and then the second time by cosine squared, and create 2 more identities. Tan squared plus 1 is secant squared, 1 plus cotangent squared is cosecant squared. Then we looked at the graph of sine and cosine, and first and foremost, we looked at a complete cycle, which is from 0 to 2 pi, simply because the period is 2 pi. And there are different methods. One method was to cut them into 5 key points, 4 arcs, and therefore 2 pi is cut into 4 sub-intervals. 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and 3 pi over 2 to 2 pi. And the endpoints result in these 4, 1, 2, 3, 4 arcs. 1, 2, 3, 4 arcs. And for example, sine is 0, 0 here, pi over 2, 1, and so on and so forth. The same thing with cosine, starts with 0. The relationship between sine and cosine is that sine is cosine of x minus pi over 2. By moving by the amount of pi over 2 from 1, we can go to the next one. If we have a basic sine and cosine, now the period is 2 pi, amplitude is 1. However, if y is a sine omega x and a cosine omega x, then the period changes to 2 pi over omega, and amplitude is absolute value of a. So this is basically the synopsis of what we needed to do. Now, we also added phase shift. So y equals a sine omega x minus phi. So we take the omega out, and it's a sine omega times x minus phi over omega. This creates the phase shift of phi over omega plus b, creates up and down along the y-axis. So amplitude is still absolute value of 8, period is still 2 pi over omega, and the phase shift is phi over omega. It's important to take this omega out, so you see this is the phase shift. When phi is less than 0, phase shift is to the left, and if phi is positive, phase shift is to the right. And I think I mentioned in some text they use a sine b x minus c plus d. So it's just a matter of preference for the variables, that's all. And let me write that in case. So in some text, they may use different variables, a sine b x minus c plus. They may use it in this format. Okay, it doesn't matter. The concept is the same. Now, the inverse sine, cosine, and tangent functions. First, let's look at properties of functions and their inverse. Only one-to-one functions have inverse functions. Their composite function, f of f inverse of x equals x. X is in the domain of f inverse, and f inverse of f of x equals x. X is in the domain of f of x. So in this case, x is in the domain of f inverse. In this case, f inverse of x is in the domain of f of x. All right. The domain of f of x is the range of f inverse, and the range of f of x is the domain of f inverse. So in short, domain of one is range of the other. Domain of one is the range of the other, in short. The graphs of f of x and f inverse x are symmetric about the line y equals x when graphed on the same axis. Composition of inverse functions. F of f inverse of x equals x, and f inverse of f of x is also x. Their composite function, f of f inverse and f inverse of f, are identical, and they are both equal to x. So we want to come up with the sine inverse. Sine fails the horizontal line test. In fact, all trigonometric functions fail the horizontal line test because they are periodic. None of them is a one-to-one function. So the only way to make that happen, you have to restrict the domain. So when you want to restrict the domain, you want to make sure all the range is covered. So if we restrict it from minus power 2 to power 2, it covers everything from negative 1 to 1. So y equals sine x. X is between negative infinity and infinity. Y is between negative 1 and 1. And it's, as you can clearly see, it is not a one-to-one function because it's a periodic function. It is not a one-to-one function. However, if we choose this portion only, the restriction, now comes the restriction. Y equals sine x. Now we restrict the domain from minus power 2 to power 2. The range remains the same because we have to cover everything. And now this is a one-to-one function, and that's really the key. This is a one-to-one function, everybody. So y equals sine inverse of x. By definition of inverse function, x equals sine y. X is between -1 and 1. Y is between minus pi over 2 and pi over 2. So the inverse function, we reverse the domain and range. Notice here's the domain, here becomes the range. Here's the range, becomes the domain. And so let's look at the way we're going to graph, and by looking at those three easy points. This point, minus pi over 2 minus 1, 0, 0, and pi over 2, 1. So according to the inverse function, all you have to do, interchange x and y. So those 3 points change to -1, negative pi over 2, 0, 0, 1, pi over 2. And all you have to do, draw those 3 points. When we do that, -1 pi over 2, 0, 0, the same as that one, 1 pi over 2, and the graph looks like that. So we are looking at sine inverse and sine x at the same time, and we notice the graphs are symmetric with respect to the line y equals x. A warm-up example, we are interested in finding sine inverse of 1. We are interested in finding sine inverse of 1. First, reminding you of what we had in the previous page, y equals sine inverse. That means x is sine y, where x is between -1 and 1, and y is between negative pi over 2 and pi over 2. Having said that, what is this? Let's set it equal to x, y, theta, anything. Normally, we can go with theta or alpha because that represents an arc. And by definition of the inverse function, this means sine theta must be 1. And you know the answer to that. Sine theta equals 1, theta must be pi over 2. Okay. Remember the restriction we did? And it's one of those common arcs. What about sine inverse of 1/2? Again, we set it equal to something, alpha, beta, gamma, theta. By definition of an inverse function, sine of theta becomes 1/2. And between negative pi over 2 and pi over 2, there is only one answer. Theta is pi over 6, or 30 degrees. Sine inverse of -1/2, again, we set this equal to, again, let's say theta. By definition of an inverse function, sine of theta must be -1/2. And again, remember, the restriction is from minus pi over 2 to pi over 2. As you know, if you look at positive 1/2, the reference arc is pi over 6, or sine. And this goes from the fourth quadrant to the first quadrant. In the fourth quadrant, sine is negative, so that makes it minus pi over 6, minus pi over 6. They were all common arcs. Uh, we knew the answer. There was no need for a calculator. But what happens if we want to approximate it because it's not a common arc? So find the approximate value of an inverse sine function, answer in radians with 4 decimals. So to answer these, now we don't have a common arc. So of course, if we write this equal to theta, by definition, sine theta equals 1/3. That's the meaning of it, agreed. However, because it's not a common arc, we don't know the answer. So if you use a calculator, sine inverse of 1/3 gives you that. And we want 4 decimals, 1, 2, 3, 4, number 8. Next to it is 3, number 8 doesn't change. So make sure you understand this is the reason it doesn't change. If it's 5 or above, it changes. So 0.3398. Again, if you set it equal to theta, that means sine theta is negative 1/4. And it's not a common arc, so we have to put it into a calculator. Sine inverse of negative 1/4 is this number. Again, we want 4 decimals. So minus 0.1234. Now we stop at 6. Next to it is 8. We take it up a notch. Okay, 0.2527. I thought I had 27. So there's a typo here. Let me fix that. 27. What is sine of sine inverse of 0.5? Well, I'm going to remind you that f inverse of f and f inverse and f of f inverse, they are both x as long as we have the right domain. In this case, when we say f inverse of f of x, that means sine inverse of sine x equals x. This would be the case because we are dealing, remember, this is the one that has been restricted. So the x must be between minus power 2 and power 2. If we go with this one, sine of sine inverse of x equals x, remember the inverse, that means the range of this guy, which is from -1 to 1. Okay, the restriction, -1 to 1. Since we are looking at this format, everybody, and this number is between -1 and 1, the answer is 0.5. If you put it into a calculator, you get to the same answer. What happens here? Again, we are looking at the same format. And this number must be between -1 and 1 to be x. If it was any number between -1 and 1, the answer would be that. If it was 0.8 or -0.8, we would say 0.8 or -0.8. But it's 1.8, it makes it undefined because this number is larger than 1. But it must be between -1 and 1 only. And if you go with a calculator, it gives you an error. All right, pretty straightforward using a calculator. Um, Without the calculator, we can handle it as well. Pretty simple. All right. Find the exact value of the following composite function, sine inverse of sine of pi over 8, and again, reminding you of this information. Now, because we are looking at the sine, look at the inside. Sine, the restriction is from negative pi over 2 to pi over 2. Remember that. We had to restrict a domain for the sine in order to make it a one-to-one function. Is this between these two values? The answer is yes. And I write pi over 8 is an element of the way we read this. It's an element of this. Let me write that. Because it is, the answer is pi over 8. What about sine inverse of sine of 5 pi over 8? We look at the same thing. Is this arc angle between these two values? If it is, the answer is itself. But it's not. Remember, 5 pi over 8 is larger than 4 pi over 8, which is pi over 2. So it's not. Meaning, this is in the second quadrant. For sine, the restriction is from the fourth quadrant to the first quadrant. So that's not the answer. So what do we have to do? When that happens, it does have an answer. Unlike the previous page, where sine of sine inverse of 1.8 didn't have an answer. This one does have an answer, but it's not 5 pi over 8. We have to find the answer. So what is the process? Find an angle in this interval for which sine theta equals sine of 5 pi over 8. So somewhere here, there must be an angle whose sine value is the same as sine of 5 pi over 8. Now, what is 5 pi over 8? 5 pi over 8 is an arc that belongs to the second quadrant. In the second quadrant, you know sine is positive. So all you have to do, find the reference arc for that, which is 3 pi over 8. So if you look at 5 pi over 8, everybody, it's reference arc. Remember, the reference arc is the angle that the terminal side makes with the x-axis, the closest one. In this one, the closest one is this side, is 3 pi over 8. And because that's the arc, the sine has the same value, or any other function, any other trigonometric function, you just pay attention to the sine. The sine has a positive sign, but for example, if it were cosine, would be negative. So this is the same as 3 pi over 8, sine of 3 pi over 8 accordingly. Okay, if you look at that, you'll see that. Remember, this is A over R cosine. Okay, B over R is sine, and B is the same, and the same sign, both positive, whereas A, for example, would be the negative of the other. And so sine inverse of sine of 5 pi over 8 is the same as sine inverse. We're going to replace this with sine of 3 pi over 8 because they both have the same value. Therefore, the answer is 3 pi over 8. Okay. So I think it's pretty straightforward. In short, you need to find the value, the arc that gives you the same value. And pay attention, of course, that this is positive. So the answer is 3 pi over 8. Let's deal with the cosine. Cosine has the same situation as sine. It's a periodic function, and therefore it's not a one-to-one function. So y equals cosine x. X is between negative and positive infinity, and y is between negative 1 and 1. Therefore, it is not a one-to-one function. So what to do, what to do? Well, we go through the same process, and we do this restriction. The reason we do this restriction, number one, the range must be all there. Number two, we don't want to come up with two pieces that are separate. We want it to be continuous. So if we go from here to here, which means from 0 to pi, it will do the job, okay? And we're going to stick with that. So y equals cosine x. We restrict the x between 0 and pi. The domain, which was negative to positive infinity, is restricted. The range doesn't change. And now this, as you can see, it's a one-to-one function. So y equals cosine inverse of x. That means x equals cosine y by definition of an inverse function. X is between negative 1 and 1, and y is between 0 and pi. I can't emphasize this enough to remind everybody that domain of one becomes the range of the other. Domain of one becomes the range of the other. So this is the domain for cosine becomes the range for cosine inverse. This is the range for cosine x. Y equals cosine x becomes the domain for cosine inverse. So let's look at those pairs, 0, 1, pi over 2, 0, pi, negative 1. Those are the ones on the function of y equals cosine x. So corresponding to those pairs, now we're going to have, for the inverse function, interchange x and y. 1, 0, 0 pi over 2, negative 1 pi. And all you have to do, plot those. So if you were to use here, this would be 1, 0. 0 pi over 2. Pi is about 3.1415, and it continues indefinitely. So 1.57. So somewhere here, 0.0 and 1.57. And then minus 1 is here and go up there for pi, which is 3.14. So looks like this. 1, 0, 0 pi over 2 minus 1 pi. Now, if we put it on the same axis, notice symmetric with respect to the line y equals x. By the way, if the two graphs ever intersect, the point of intersection must be on y equals x, because the x coordinate for one becomes the y coordinate for the other. And that's the reason and it's important to pay attention to that. All right. Find the exact value of an inverse cosine function. We want cosine inverse of 0, and of course, cosine inverse 0, let's say it's theta. So you have to set it equal to some variable, alpha, beta, gamma, theta. By definition, cosine of theta must be 0. A common arc, you know the answer, theta is pi over 2. And again, I wrote the information from the previous page. We do the same thing here. You set it equal to some angle, for example, theta, by definition. Cosine of theta must be 1/2. That's a common arc. Anybody remembers what theta will be? Remember, it's a common arc. Theta must be what? Anybody?
Pi over 3.
Pi over 3. Perfect. Cosine inverse of negative 1/2, we do the same thing. We set it equal to theta, let's say. By definition, cosine of theta must be negative 1/2. Negative 1/2. Now again, remember right from here, pi over 3, when we have a positive 1/2, pi over 3 becomes the reference angle for this. So that should help you figure out what the answer is, okay? That's why actually I put them next to each other. So 1/2, we ended up with pi over 3. We remember that it's a common arc. And therefore, for negative 1/2, we really have pi over 3 as a common arc. And the restriction is that we are going to look for 0 to pi. In the first quadrant, cosine is positive. In the second quadrant, cosine is negative. So can anybody give us the answer here? Theta must be 2 pi over 3. Why is that? Pi minus pi over 3. Okay. This is pi over 3. This distance is pi over 3 also. And to find this angle, you subtract pi over 3 from pi. Again, I am reminding you about how to use a reference arc. All right, we do the same thing here. We set this equal to theta. By definition of an inverse function, cosine theta is negative square root of 2 over 2. Again, just to figure this out, I want you to remember that if cosine is square root of 2 over 2, theta is pi over 4, which makes pi over 4 the reference arc. Now this is negative. It's in the second quadrant. So now this much is pi over 4. So subtract it from pi. So pi minus pi over 4, which is 3 pi over 4. Again, I'll show you that here. So this value is pi minus the reference arc pi over 4. You should really be very comfortable with that as we have an exam regarding this concept. All right, we are going to move on. In this case, we are to find the exact value of the following composite functions. Let's see how we do that. Again, reminding everyone that the cosine inverse of cosine is x, cosine of cosine inverse is x, as long as this is in the right place, okay? And that's really important, as long as this thing works properly, meaning in this case, x must be between 0 and pi. In this case, x must be between negative 1 and 1. So we are looking at this one. We are looking at this one. And remember, for cosine inverse, we decided the first and the second quadrant from 0 to pi, the 5 pi over 6 less than 6 pi over 6, which is pi. Therefore, it belongs to 0 to pi, and therefore the answer is 5 pi over 6, because 5 pi over 6 is in the vicinity of 1 and second, in this case specifically second quadrant. That works. Cosine of cosine inverse of some number, in this case 0.2. This number must be between -1 and 1 to give us the same answer. Is 0.2 between -1 and 1? The answer is yes. Therefore, the answer is 0.2. 0.2. Let's look at this case. Okay, so we are looking at this one. Is 5 pi over 4 between 0 and pi? Obviously not, because this is larger than pi. So 5 pi over 4 is not between 0 and pi. So what do we have to do? We have to find an angle with the same cosine value. 5 pi over 4 is in the third quadrant. In the third quadrant, cosine is negative. The reference arc is used, and the reference arc is pi over 4. So let me write that. For 5 pi over 4, the reference arc is pi over 4. Remember that. And because this is negative, and it's in the third quadrant, we have to use this second quadrant. The second quadrant, pi minus pi over 4 gives you the same answer. Again, I want to make sure we understand. The reference arc is pi over 4. So the functional value of pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. The functional values are the same, some of them positive, some of them negative. So for example, this guy, everything about it is positive, including cosine of pi over 4. Okay? These two, both of them are negative. This is in the second quadrant, this is in the third quadrant, because cosine is negative in the second and third quadrant. But in the fourth quadrant, which is 7 pi over 4, for example, is positive. Because this is the case, we can see the answer is 3 pi over 4. So cosine inverse of cosine of 5 pi over 4 is the same as cosine inverse of cosine of 3 pi over 4. Therefore, the answer is 3 pi over 4. So you have to find an angle with the same cosine value. What about cosine? Cosine inverse of 2 is 2 somewhere between -1 and 1. The answer is no. Therefore, it's undefined, because 2 is larger than 1. You can say 2 doesn't belong to this interval of -1 to 1, or you can say two is larger than 1, therefore it's not good. You can go with that route if you want. It's the same thing. Okay. All right, tangent functions. As I mentioned, none of the trigonometric functions are one-to-one. None of them has an inverse unless you restrict it. And this is a periodic function tangent, and therefore it doesn't have an inverse unless we do the restriction. So y equals tan x goes between negative and positive infinity, x can't be in pi, and y is between negative infinity and infinity. Therefore, it's not a one-to-one function. It is not a one-to-one function, and I can't emphasize this enough. Therefore, the way it is, it doesn't have an inverse. The way it is, it does not have an inverse. So what do? We just look at a complete cycle from negative power to power 2, just like in essence, the restriction, just like sine, of course, the endpoints negative power 2 and power 2 are not included because those are vertical asymptotes and the function blows to infinity here and negative infinity here. So here's how it works. Y equals tan x is between negative power 2 and power 2, that's the restriction. We have the same range, the range doesn't change, but now this function is a one-to-one function. So we write y equals tan inverse of x. That means x equals tan y. X is, remember here, the range y is between negative and positive infinity. Now the domain x is between negative and positive infinity. Over here for tan x, the domain goes from negative power 2 to power 2. In this case, the range y goes between negative power 2 and power 2 for tan inverse. So let's write a few interesting facts about tangent. For example, we know this is 0, 0. We know it's a famous negative power 4, negative 1, power 4, 1. The vertical asymptotes are for just one complete cycle, x equals minus power 2 and x equals power 2. So that's what we have. For its inverse, the tan inverse, this one becomes negative 1, negative power 4. This is the same 0, 0. This becomes 1 comma power 4. What happens to the VA? VA changes to the HA, horizontal asymptote, y equals minus power 2, and horizontal asymptote, y equals power 2. So that's the change that takes place. That's the change that takes place. So when we look at the graph, now the 0, 0 doesn't change. As I said, power 4 becomes 1 pi over 4, negative 1, negative pi over 4. So over here, so it's hard to see 1 and power 4, negative 1, negative power 4. And now look at the vertical asymptotes become the horizontal asymptote. So it goes towards the horizontal asymptote. And this is among the rare functions that has two vertical asymptotes, horizontal asymptotes, two horizontal asymptotes. Y equals pi over 2, y equals negative pi over 2. We want to find the exact values, and on purpose, we have chosen all of them to be a nice and easy common arc. So pretty much we can handle it without a calculator. So let's start with the first one, where tan inverse of 1 is given. Let's say it's alpha, beta, gamma, theta. By definition, tan of theta becomes 1. And we know theta is pi over 4. Part B, set it equal to theta. By definition, tan of theta becomes minus the square root of 3. And remember the restriction from minus pi over 2 to pi over 2 for theta. So it makes square root of 3 is pi over 3. Negative square root of 3 is minus pi over 3. In the fourth quadrant, sine is negative, tangent is negative, okay? Now it's time for this one. We do the same thing, let it be equal to theta. By definition, tan of theta must be square root of 3 over 3. And as you know, this is a common arc, pi over 6. Last one, we do the same thing, set it equal to theta. By definition, tan of theta must be minus square root of 3 over 3. If this was pi over 6, this must be negative pi over 6. Fourth quadrant. Because of the restriction, we put on theta to be between negative pi over 2 and positive pi. We want to solve some equations involving inverse trig functions, starting with 2 cosine inverse of x is pi over 2. We're going to divide both sides by 2. So cosine inverse becomes pi over 4. By definition, x must be cosine of pi over 4. And we know cosine of pi over 4 is a common arc, and it's square root of 2 over 2. Three sine inverse x is pi over 2. Let's divide by 3. So sine inverse of x is pi over 6. Therefore, sine of pi over 6 is x, a common arc. Sine of pi over 6 is 1/2, and it's done. Five sine inverse of x minus 2 pi equals 2 sine inverse of x minus 3 pi. So I hope you see that sine inverse and sine inverse are identical, so we can move things around as follows. If I move this way, becomes minus 2 sine inverse of x. If I move negative 2 pi, becomes positive 2 pi on the right. So these two, 3 sine inverse of x. These two, negative pi. Divide by 3. Sine inverse of x is minus pi over 3. Therefore, sine of negative power 3 and x must be the same. So x is sine of minus power 3. And this is the same as minus sine of power 3. Either use that, or just you may know the sine of power 3 is square root of 3 over 2, and the negative power 3 makes it negative square root of 3 over 2, because in the fourth quadrant, sine is negative. So minus the square root of 3 over 2 by any means. Find the inverse function f inverse of f of x equals 2 sine x minus 1. X is between negative power 2 and power 2. Find the range of f and the domain and range of f inverse. So we want to find the domain and range for all of them given this function, 2 sine x minus 1. We want to find the inverse, and for this function, the domain is between negative power 2 and power 2. So remember how we find the inverse. First, we change this to y because it makes it easier. You're looking at this function, okay? We change the f of x to y because it makes it easier to work with. Interchange x and y. This becomes x, this becomes y. And right here we have the inverse. However, we always solve for y. To solve for y, I'm going to move the negative 1 to the other side. Becomes x plus 1, and I'm going to divide by 2. I'm going to assume everybody's okay with that. So move the negative 1, makes it x plus 1, divide by 2. And then divide by 2. And so now, by definition of an inverse, sine inverse of x plus y over 2 is y. This is the concept of a sine inverse. You can go from here to here. You see that? From here to here. And we change the y to f inverse of x. So we found the inverse. We want to discuss the domain and range. If this is the domain, for the function must be also the range for the inverse. Domain of f of x is given, okay? That means range of f inverse is given. So that's very straightforward. Now, domain of f inverse, remember, sine inverse, don't even look at that. If you completely just, if you ignore that, sine inverse, okay? Whatever this is, must be between negative 1 and 1. Okay, sine inverse of x must be between negative 1. This expression, this argument must be between negative 1 and 1. Solve for x. So I'm going to multiply by 2. Because I want to get rid of that. This becomes minus 2. This becomes positive, so this 2 goes away. I'm going to subtract 1 from all 3 sides. X is between negative 3 and 1. So this is the domain of f inverse, which makes it the range of f. So range of f, y is between negative 3 and 1. So this one we proved, this one by the definition of an inverse. I'm going to quickly show you a different method. in case you're more comfortable with that method. Second method, y is 2 sine x minus 1. So if you solve for sine, you take the 1 to the other side and you divide by 2, right? And remember, sine is supposed to be between -1 and 1. So this is supposed to be between -1 and 1. Sine is supposed to be between -1 and 1. So y plus 1 over 2 must be between -1 and 1. If you multiply by 2, put it at top here, you get -2 less than or equal to y plus 1 less than or equal to 2. And now positive 1. Subtract from both sides. So -1 here, -1 here, -1 here gives you this answer, -3. Y is between -3 and 1. This is the same as what we got here. And I'm going to also look at another method quickly. That may even be more easily understood for some students. Here's quickly the third method. We know sine is always between -1 and 1. So make it look like this. How do you make it look like this? Well, first I need to multiply by 2. I multiply by 2. This is -2. This is 2 sine x. This is 2. Then I need to subtract 1 from every side. If I subtract 1, this becomes -3. This becomes 2 sine x minus 1. This becomes 1. And it's between -3 and 1, the same as here. So 2 sine x minus 1 represents the y, right? This is another way of doing it. Again, ultimately, they are pretty much the same. I just wanted you to be exposed to various methods and see what works for you. Here's another example where f of x is given as 2x cosine of 3x plus 2. We want to find the inverse, and the domain is given that x is between 2/3 and -2/3 plus pi over 3. It's given in that format. Okay. So I hope everybody is understanding the situation and the question. Well, let's find the inverse. And to find the inverse, the very first step is to change f of x to y because it's easier to work with it. Interchange x and y. This becomes x, this becomes y. And right here we have the inverse. We want to solve for y, therefore, first we want to get rid of the 2. So let's divide both sides by 2. So this expression, x over 2 is cosine of 3y plus 2. Therefore, by the definition of an inverse, cosine inverse of this expression is 3y plus 2. You want to solve for y, we're going to subtract the 2, then we're going to divide by 3. So let me quickly show you that. So we are going to get rid of this and say this is -2. So if 3y equals cosine inverse of x over 2 minus 2, then we divide both sides by 3, or we multiply both sides by 1/3. Class, I can multiply this one now by 1/3 and this one by 1/3. And I have y, or f inverse of x, is 1/3 of this expression, x over 2 minus 2. That's the whole thing. Now, 1/3 of -2 is -2/3. Let me write it on the side just to make sure you can see that in case you have problem following that. So and I'm going to erase it. So cosine inverse of x over 2, we subtract 2 and it becomes 3y. We are going to multiply both sides by 1/3 and we get 1/3 cosine inverse of x over 2 minus 2/3 equals y. And now we change the y to what? F inverse of x. And that's what we get here. Okay. All right, I hope it's clear how we arrived at it. So let's clean up the mess. Let's do this. And so now the domain of f of x, x over here, is between these two values. That means the range of this function, y, is between those two values. That's just by definition of an inverse. So this comes from the definition of an inverse. You don't have to do anything. This is given, so therefore this is given. What about the domain of f inverse? Domain of f inverse. If you look at the argument of the inverse cosine, that argument must be between -1 and 1. So x over 2 must be between -1 and 1. To get to x, you multiply by 2. If you multiply everything by 2, you get this one. X is between -2 and 2. And so the range is between -2 and 2. And what I want to do, I'm going to go over the second method that I think it might be a tad easier for some people to follow. So let's do the second method on that, just as we did it previously. Range of f method 2. Okay. We know y is 2 cosine of 3x plus 2. And we know cosine, doesn't matter what the argument is, must be between -1 and 1. This is the easiest and fastest way. We are interested in finding the range of this function, right? F of x. Cosine of whatever the argument of, this is called the argument. It's the argument of cosine. And regardless of what the argument is, cosine is always between -1 and 1. Since this is 2, let's multiply everything by 2. That's why the range is between -2 and 2. All right. We want to find the inverse function of f of x equals 2 tan x minus 3 when x is between minus pi over 2 and pi over 2. So let's work on this one. So first and foremost, f, we change it to y because it's easier to deal. X becomes y, y becomes x. Interchange x and y. Again, right here, we do have the inverse, everybody, but We have to solve for y. So move the -3 class. If I get rid of this, this becomes x plus 3. And I'm going to divide by 2. I'm going to divide both sides by 2. And so this is tan y. By definition of an inverse function, y equals tan inverse when x is tan y. So tan inverse of this expression is y. And y, now we change it to f inverse. So y or f inverse is this expression, tan inverse of x plus 3 over 2. And because this is the domain of f, everybody, this is the domain of the f function, must be the range of f inverse. And domain of f inverse, x plus 3 over 2, remember, domain is between negative and positive infinity. That means regardless of whatever this is, okay? Normally it's x, but it doesn't have. This expression is between negative and positive infinity, and so is x, because if you multiply by 2, okay, if you multiply by 2, it becomes minus 2 infinity, becomes 2 infinity. It is still infinity. And then if you subtract 3, I hope you see that. Maybe I can quickly show you. If I multiply by 2, this goes away. This becomes 2. This becomes 2. Now, if I subtract 3, I get minus 2 infinity minus 3 less than or equal to x less than or equal to 2 infinity minus 3. By the way, infinity minus 3, infinity times 3, infinity times 10 minus 10,000 is still infinity, and negative infinity minus or plus any number is the same. So if I want to give you the second method quickly, 2 tan x minus 3, we know that tangent is between negative and positive infinity because of the range of tangent itself. So if I multiply this by 2, this is minus 2 infinity, this is positive 2 infinity, and it is the same. If I subtract 3, so this is minus 2 infinity minus 3, which means the same thing. And this is 2 infinity minus 3, which is still the same thing. So whether you go this route or this route makes no difference. And I think it's pretty straightforward, everybody. We are going to do the same thing here. We want to find the inverse. So first and foremost, f changes to y because it makes it easier. Now we interchange x and y. If I subtract 1 and I divide by 3, I get cosine 1. So in short, interchange x and y, solve for cosine y. And right here, by definition of an inverse, y is cosine inverse of x minus 1 over 3. And cosine inverse of x minus 1 over 3, or y, we also call it f inverse of x. So we found the inverse. What about the domain and range? This is the domain of f of x given. And again, recall that the domain of f is the range of f inverse, and the range of f is the domain of f inverse. So we already know that this is given. So if this is the domain for f, this is also the range for f inverse. y, okay. Y is between 0 and pi. Domain of F inverse is between -1 and 1. That means x minus 1 over 3. See, x is between -1 and 1. That means whatever this x is, I want to emphasize this. When we say x, we mean this expression, whatever this expression is, which happened to be this expression now. Okay, that's y, everybody. That's y. So this expression must be between -1 and 1. Well, let's multiply by 3. This becomes -3. This goes away. This becomes 3. Let's add 1. And becomes -2 to 4. So this is the domain of F inverse. Domain of F inverse, which means range of F, y is the same thing, -2 to 4. Again, a second method. We want to work on 3 cosine x plus 1, so we start with cosine. We know cosine is between -1 and 1. So if I want it to look like this. I'm going to multiply by 3. This becomes -3. This becomes 3 cosine x. This becomes 3. I need the 1. I'm going to add 1. This becomes -2. This becomes 4. And that's the same answer as we got here. All right. And that's it, class. Happy studying.